Okay, beautiful people. So we are, let's see, start recording. There we go. Okay. So we're looking at the module 5 unit test. We're going to go over the answers. I'm going to explain this as best as I can, kind of in reteach mode for those of you that did not do as well on this assignment as what you had thought. Either you didn't finish your classwork, or you made some careless mistakes, or you were unsure about combining the terms, whatever the reason. If you did poorly on the test, I'm going to give you an opportunity to do corrections where you put down what you should have gotten and explain what you did wrong or how to do the problem correctly. If you do that, you will get half credit back. And of course, the highest score would be an 80. But we're just going to go over these real quick. It's not going to take a long time because I'm going to be in like fly through mode, and I've printed off this answer sheet that has the key with it. And so hopefully, everybody will kind of see and understand how to do the problem. So the first one was write the problem, the quantity 6/7 multiplied times itself 1, 2, 3, 4, 5 times using an exponent. And we actually went over this before the test. And to do that, because you've got to multiply the numerator and the denominator by the same number of times or repeated factors, it would be written in parentheses for the fraction, and then the exponent would be outside of the parentheses. So that's written as the quantity of the fraction 6/7 parentheses closed raised to the fifth power. That's what that would look like. So pretty easy there, cut and dry. On the next one, it was a volume of a cube, and you have the formula here. Volume equals length times width times height. It's a cube, so they're all the same. So that means 4.7 times 4.7 times 4.7. On this one, there was a calculator in the side tools. There was a calculator in your tools that was available for you to use. You would have just multiplied 4.7 times 4.7 times 4.7. The correct answer is 103.823. That written as an exponent is 4.7 to the third power. And on part 2B, they have you writing it as with using an exponent. So that would be just simply 4.7 raised to the third power, because that is a decimal, or you could have written the quantity of 4.7 to the third power. That's all there is to that. Pretty simple. Just repeated multiplication of the same factor 3 times. Number 3 was looking at an equivalent expression or equivalent expression to 7 to the fourth power. What that means is 7 multiplied by itself 4 times. So here I have 1, 2, 3, 4, 5, 6, 7 fours. That cannot be it because I'm not even multiplying 7 there. Here I have 7 times 4. You do not multiply the factor times the exponent. Here is 16,384, which even if I use the calculator from our problem, if I did the number 7 raised to the fourth power, that answer is 2,401. So it's going to be this one. It's not going to be that. It's not going to be that. And it's also going to be this one. So these are the two answer choices that you should have selected for the expression 7 to the fourth power. Okay, moving right along. All right, on this one, this was a pattern problem. It says Jasmine is studying the growth of mold spores on a piece of bread. She puts 4 spores on the piece she puts 4 spores on the piece of bread and records the number of spores over time. She records the results over 12 hours in the table shown, and she notices a pattern. So If you look at her 12 hours that she has here, notice she's counting by threes. Every 3 hours she's checking it. 3, 6, 9, 12. Every time it increases 3 hours, the mold spores are multiplied or quadrupled or multiplied times four. So in the first 3 hours, it's 4 times 4, or that's the same thing as 4 squared. Sorry, which is 16. If you were in the building, come to the then, office. After 3 more hours, it's to the third power, which whatever 16 times 3 is, I think it's 40 something, but 16 times 3 equals, you had a calculator or anything. Yeah, that's 48. So this is 16, this is 48. The next one would be 144. And basically you could do this 16 times 16, which no, that's not right. 4 times 4 is 16. Let's see. 4 raised to the fourth power is 48 times 4. And that's 192. No, 12 times 12 is 144, not that. So this one is wrong. I wrote it wrong. So that would be 192. And basically, you had a calculator that you could use in your toolbar, but every 3 hours, the exponent is multiplied by itself one more time. So 4 squared is 3 hours. 4 to the third is 6. 4 to the fourth is 9 hours. 4 to the fifth is 12 hours. So we're going to keep going until we get to 21 hours, which means if you're counting by threes, if 12 is 4 to the fifth, then 15 is going to be 4 to the sixth power. 18 is going to be 4 to the seventh power. And 21 hours is going to be 4 to the eighth power, because we're still increasing by each one. And 4 to the eighth power would give us 65,536 spores. Or you could have written as 4 to the eighth power. Either one would have been correct, or you could have written them both. You can see here they have the exponent form and the numerical form. And there goes my light in class. It timed out. There we go. So that would be the correct answer to that. And again, on this one, you did have a calculator. So you could have multiplied that however you chose to. But if we did have 4 to the eighth power, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so if we did this, you could basically, if you didn't have a calculator, combine these to 16 times 16. 4 times 4 is 16. 4 times 4 is 16. 4 times 4 is 16. So you could have just multiplied 16 times 16 times 16 times 16, and it still would have been the same answer. That's if you were using the multiplication, just had to multiply it out, and you didn't have a calculator in your toolbar. The main thing about that problem was recognizing the pattern and seeing how with every 3 hours, the number of mold spores multiplied by 4. All right. And to evaluate the expression, that's just simplifying what you have. And remember, when we do these, we're using the order of operations, and everything that you have, or everything that we've worked on with the order of operations, has applied to both numerical and algebraic. So even though this is just a numerical expression, if you look at this and we break this down, following the order of operations, we should easily come up with the answer. So if I start with this one, I'm going to start with the parentheses, and you multiply before you subtract. So 3 times 5 is 15, and 15 minus 3 is 12. Okay, so in the parentheses, we have 12. So then we have 1/2 squared, which is 1 times 1 is 1. 2 times 2 is 4. That would be 1/4 times 12. and then plus 1 to the third power, which 1 to the third is always just 1. And what we do here, anytime we're multiplying by a fraction, you're actually you can divide by the denominator. That would be like 12 over 4, and 12 over 4 is actually equal to 3, and 3 plus 1 is 4. So here you would have 3 plus 1, simplifying that, and your answer, the correct answer would be 4. Okay. The next problem. This is a problem where you're creating an expression. It says Mel's selling makeup for a new skincare line. She sells face wash for $28, face lotion for $23, and an exfoliating scrub for $32.18. She also sells a sample size of makeup trial for $3. At her first skincare party, she sold 5 bottles of face wash, 2 lotions, and 3 sample size makeup trials. Write an expression to represent the total cost of the product sold. Okay, so this is pretty easy because we have each thing's price. If you look at what we have, we've got the lotion, the wash, the scrub, and the samples, but it says she has 5 of the face wash. We know the face wash is $28. So the number she bought was 5, and she paid $28 for each one. So 5 times 28 would be that one. She had 2 lotions, which the lotions is 23. So that would be the quantity of 2 times, this is not division. I shouldn't write it like this. But she had 2 at $23. And I'm just putting the dollar sign here so you know it's money. But in our equation, we don't. And then she had 3 sample size makeup. So she had 3 samples, and those were $3 each. So if you look at what we have, this is showing a model for the expression, and you've got 5. If I look up here, what did I have 5 of? That was the face wash. So that's going to be 5 times 28. Plus, what was $23? That was the lotion, and I had 2 of those. So that's going to be 2 times 23. And then we have 3 of the samples, and that's going to be 3 times 3. And to combine those and get the answer, you would do the operations, but it's just asking you for the expression. So the expression will be 5 times 28 plus 2 times 23 plus 3 times 3. So that's how that would be worked out. And of course, you could solve it, but it's not asking you for that. It's just asking you for what would the expression be. And that's how you write the expression. All right. So on the next question, it is identify the terms, the like terms, the coefficients, and the constants. And of course, we had this on the board and we talked about it yesterday and we went over it again today. So hopefully you got this one right. But when you look at your expression, of course, I always rewrite it when it is online so that I can see. But when you look at your expression, we have 3s, 1/2, 4s squared, 6s, and 9. That's all of our terms that are in this expression. And when we break this down and look at each individual part of the expression, it's a little bit easier to see. It's a little bit easier to see how this would break down. Now, what I always do, I take the operations and I include the operation sign with it, and clearly you can see that the terms are easily divisible. We're looking for the terms, the like terms, the coefficients, and the constants. So if I look at this, the 3, the 4, and the 6 up here, where I have 3, 4, and 6, all of those numbers are with a variable. So anything that is with a variable is a coefficient. So the first one would have been coefficient because those are with variables. So I just put that there so you would kind of know. If we look at the 3s and the 6s, well, here I have the 3s. Here I have the 6s. I don't have any other s terms, so that has to be the like terms because they would go together. They have the variable, they would go together. Now, also, if you look, the 1/2 and the 9 could be combined, but because it just has these listed, these are like terms. The 1/2 and the 9 by themselves are not like terms necessarily, because it's not listed with the 3s and s. So those are the numbers that don't have a variable. Those are constants. And we would just put those together. And then you've got 3s, 1/2, 4s squared, 6s, and 9. Those are all the terms that make up the whole expression. So we went over those, and we've talked about those quite a bit before. The main thing is understanding that you cannot put variables that are written differently together. So if I have an s and an s squared, it cannot go together. You can only put s's with s's and s squared terms with s squared terms. All right, number 8. It says match the algebraic expression to the verbal phrase. So when we read these, before we do anything, we want to make sure that we understand what the selections are. And on this, before I even read that, I'm going to look at what I have here. So I have 10 plus 2b. Okay, I have 4b plus 10. I have b minus 10. I have 10 minus b. And I have 10 plus b divided by 2 and 10 times b minus 4. Now, looking at these and saying what they are helps me to recognize the words. When I look at these two that are very similar, where I'm adding, where I'm subtracting here, I have b minus 10 and 10 minus b. Those are kind of opposites. B minus 10 means I'm taking 10 away from b, or that's 10 less than b. 10 minus b means I'm taking b away from 10, or that's b less than 10. And on the 10 times b minus 4, this is 4 less than 10 times b, or it is 10 times b minus 4, or it could be 10b more, but technically, since it's going to be subtraction, it's either going to say less than or less or minus. So that's easy to kind of sort out. When you see it in words, if you have the phrases down here and you understand what this means, it's easier to match it up. So let's look at the first one. The first one is 10 fewer than the librarian's number of books. So 10 fewer means that I'm taking 10 away from the number of books. So the 10 is coming out of the book. So it's going to be b minus 10 because you're taking 10 away. It's 10 fewer. So 10 is coming out. It's 10 less than the books. And the product, the second one, the product of 4 and the number of books, b, increased by 10. So product means you're multiplying. We're multiplying 4 times the books, and then we're adding increased by 10. So let's look at the adding ones. That's 2b. Nope, here it is. 4 times the number of books. That's the product of 4 and the number of books increased by 10. Let's see. That's the only one it could be. So that one's going to be 4 times b plus 10. The next one, it says 10 times the number of books, b, decreased by 4. So you're multiplying the number of books times 10, and then you're subtracting 4 from that. So that would be the 10b minus 4. That is 10 times the number of books decreased by 4. So that's going to be 10 times b minus 4. Okay, oh, we already used that one too. Now we've got 3 left and 1 phrase. So let's look at this and see if we can narrow this down pretty easily with the words for the operations. This says 10 more than half the librarian's number of books. So you're adding 10 to half of the books. Now, if I'm halving something, I'm dividing it by 2. So I would not be multiplying by 2, so it could not be this one. I would not be subtracting the B, because that's the total number of books. That's not half of the books. Here it is. 10 plus the number of books divided by 2. That's half of the books, adding 10 to it. So that has to be the very last one. 10 plus the quantity B divided by 2. Okay, and they have B minus 10, 4B plus 10, 10B minus 4, 10 plus B over 2. Yep, we're right. I love it when I get them right. All right, let's look at number 9. It says evaluate the expression 16A plus B when A equals 3/4 and B equals 3. Now on this one, if you recall, I said you have to write these down and plug in the values, because if you try to do this in your head, you're going to either skip a step or you're going to leave something out. So we want to make sure that we replace all of these variables with the with the values that are listed for those terms. So if I have A is 3/4, that's going to be 16 times 3 over 4. That's together. That's going to be multiplied plus B. B is 3. So if I look at this, I could do 16 times 3 and divide it by 4. Or if you notice, 4 goes into 16, so I can cross simplify. 4 goes into 4 one time. 4 goes into 16 4 times. And if you look at that, that would be 4 times 3, which is 12 plus 3. Well, that's 12 plus 3. And 12 plus 3 is 15. 15 is your final answer on that. We just wrote it, plugged them in, did the operations, and then followed our order of operations to solve. Number 10, it says evaluate each algebraic expression when x is 1/3, y is 3/4, and z is 2 1/6. Then match the algebraic expression with the correct value. Okay, that's pretty easy. So if I have z divided by 1/2, z is 2 1/6. And we're going to divide that by 1/2. Now, when we're dividing fractions, if I have a mixed number, I know that I always have to make that an improper fraction, and then I'm going to multiply by the reciprocal. So if I look at this, 2 1/6, that's going to be 2 times 6 is 12 plus 1 is 13. That becomes 13 over the original denominator of 6. And instead of dividing by 1/2, we're going to multiply by 2 over 1. And looking at that, we can cross simplify here because 2 goes into 6. Or, well, you could do 13 times 2 is 26 divided by 6, but I could simplify a little bit and say 2 goes into 2 one time, 2 goes into 6 3 times, and that gives us 13 over 3. And when we simplify that, 3 goes into 13 4 times because 3 times 4 is 12. And 13 minus 12 is 1 left over with the original denominator of 3. So the first one is 4 1/3. Okay. The second one, I have y plus z. Y is 3/4. Plus z is 2 1/6. Now for this one, if we're adding fractions, you have to get a common denominator. So I'm going to write it vertically over here just so that you can see what that's going to look like. So if I have 3 over 4 plus 2 1/6, that's two fractions, I'm going to look at 4 and 6 for a common denominator. Between 4 and 6, I know that 12 is the common denominator. So 4 goes into 12 3 times, and 3 times 3 is 9. So that becomes 9/12. 6 goes into 12 2 times, and 1 times 2 is 2. So that's 2/12. And then I still have my 2 over here that I'm just going to bring down because I don't have any other whole numbers to add it to. So I'm left with 9 plus 2 is 11 over the original denominator of 12. Remember, the denominator stays the same. And I have the whole number of 2 that goes with it. So it would be 2 and 11/12, which is right here. And where we work that out, I'm just going to move it over here, 2 and 11 over 12. Of course, you would be entering that on the computer, so it's not going to be as complicated. And then the last one, we have 4 times x plus 2. So basically, you're just doing 4. X is 1/3, so 4 times 1/3, that equals 4 over 3, plus 2. So 4 times 1 is 4 over 3, so 4 over 3 plus 2. 4 over 3, 4 and 3, if I add that, that's going to be 3 goes into 4 one time with 1 left over. So let me just simplify this. 3 goes into 4 one time with 1/3 left over. 1 and 1/3 plus 2, that's a whole number, plus a mixed number. That's going to be 3 and 1/3. So that's your answer for that one. 3 and 1/3. So the first one is 4 and 1/3. The second one is 3 and 1/3. No, wait, the second one is 2 and 11/12, and the third one is 3 and 1/3. So I've got those written now. I just showed my work. When you show your work, you're going to plug in whatever values for your expression and use that to work them out. Here I worked out all 3 of them and I talked them out so you know what those are. And here's the correct answers that are listed below in order, but I showed you how to work them out so that you would know how to do your corrections. All right, on this one, I don't know why this was so confusing for this one making the flower arrangements, because it gives you the amount of each thing and it asks you to list the factors. And once you have the factors listed, you can easily see what the greatest factor is, and that would give you how many arrangements you would have. So it says you got 20 daisies and 12 roses that she's making flower arrangements. She wants to make the greatest possible number of arrangements with both flowers and wants each arrangement to have the same number of daisies and roses. So with this, I've got to determine what the greatest common factor is so that I can make groups. So the factors of 20 are 1 times 20, 2 times 10. 3 won't go into 20, but 4 will. 4 times 5. So I've got 1, 2, 4, 5, 10, and 20. The factors are 12 are 1 times 12, 2 times 6. I'm just doing these like we would do if we were doing the rainbow. 3 goes into 12, so that would be 3 times 4, and that's all of them. Nothing else goes into nothing else goes into 12. So that's all the terms or all the factors that we would have for each. So blank 1 has 2, then we have 4, 5, 10, and 20, and then we have 2, 3, 4, and 6. That is the correct answer. It's asking you what the greatest common factor of those are. And if you look between 20 and 12, 4 is the largest number that they have in common. So if I'm writing this as a grouping or a fact, if I'm factoring it, that would be 4 arrangements. And in each arrangement, that would be the other factor. So what number times 4 is 20 for the daisies, and what number times 4 is 12 for the roses? We know that 4 times 5 is 20. So for the daisies, you would have in each arrangement 5 daisies, and 4 times 3 is 12. So that would be 3 roses. So you would have 4 arrangements. You'd have 5 of the daisies, 3 of the roses in each. And that would just be using your factors and distributing your answer. So your greatest common factor is 4. The daisies, if you look right here, would be 5, because 5 times 4 is 20. And the second one, the roses, 3 times 4 is 12. So there would be 3 roses in each one. Okay. The next question is using a table, and it's showing school supplies that are left over. Now, in this, I think the confusion was people were not realizing that those totals were being divided up. But this is how many of each of the items you have: 36 pens, 48 markers, and 24 erasers. It says the bookstore manager will make packages of school supplies and sell them for $5 per package. Each package will be identical and contain the same number of items. There will be none left over. The manager wants to create the greatest number of packages. All right, so I'm making groups or packages possible, and they're all going to have the same thing in it. How much will the bookstore earn if all the packages of supplies are sold? Okay, so let's look at what we have. We know that whatever we have, we're going to sell them for $5 each. So whatever we get for the number of packages, we're going to multiply that times 5. If I look at my factors here, 36, 48, and 24, because I know my math facts, I know that 12 goes into all of these. But what I could do, I could take the smallest value, list out all the factors, and then find the greatest number of this that goes into both of these. So if I think about 24, you've got 1 times 24, 2 times 12, 3 times 6. Wait a minute. No, 2 times 12. Oh, 3 times 8, sorry. And then 4 times 6. I made that too small. So I've got 1, 2, 3, 4, 6, 8, 12, and 24. Now looking at those, come on, Mike, come on. Looking at those, I noticed right away that 24 is the largest number, but 24 goes into 48, but not 36. So it can't be 24. The next number is 12. 12 goes into 24 2 times. 12 does go into 48 4 times. And 12 goes into 36 3 times. So that's going to be the number of packages that I make, because 12 goes into all of these. 12 went into 36 3 times, 12 goes into 48 4 times, and 24 2 times. So I'm looking at those values as what you would multiply times the greatest common factor to get it. So then that would become the number of packages we made. The greatest common factor is 12. All right, so I'm going to do 12 times 5. And I know that 12 times 5 is 60. So the amount of money that they would make would be $60. $60. And if you distributed that or factored that out, you would look at what you have in order. You've got pens, you've got markers, and you've got erasers. So if each pack contains the same thing, it's got a certain number of pens, a certain number of markers, and a certain number of erasers. When I look at this, the number of pens is 36, and I know that 12 times 3 is 36, so that would be 36 pens. No, wait, 12 times 3 is 36. That means it would be 3 pens, sorry. Getting ahead of myself. Yeah. That would be 3 pens in each of the 12 packages. I'll look at 12 and I'm comparing it to 48. I know that 12 times 4 is 48. So that means there would be 4 markers. And I'll look at 12 compared to 24. 12 times 2 is 24. So that means you would have 2 erasers. So this is what is in the packages right here. And this is the number of packs. So this is the number of packs, and each pack contains that. They are the same. And we have the rate of $5 times the number of packs, and that's $60. Correct answer. All right, the next question, it says fill in the blanks using the available answer choices. 2 students are rewriting the expression 9 times the quantity of 5 plus h. Marcos writes the expression as 45 plus h. Monaj writes the expression as 45 plus 9h. Which student is correct? Okay, well, let's look at this and let's write which one it is. But first we have to distribute it. So if I have 9 times the quantity of 5 plus h, that means I have to take my 9 and multiply it times both values to simplify this, or to distribute it. So if I have 9 times 5, that is 45. Plus, I have to multiply 9 times h, that is 9h. So looking at this, the M name, the Menage, is the one who got it correct. So you would have put in your blank Menage, and that's how you would distribute it, because that is multiplying the factor outside times both values, 9 times 5 and 9 times 8, and that's the order that it would be in. The next one, we're using the greatest common factor to factor this, which means you're just taking out what goes into both of these values. If I'm looking at 28 and 42, of course, 7 goes into it, but the greatest common factor is going to be 14 because I look at the factors of 28, it's going to be 1 times 28, 2 times 14, 3 won't go into it, 4 times 7 will go into it. So I've got 1, 2, 4, 7, 14, and 28. Now, looking at this, 28 times 2 is way more than 42, so that won't be 1. Let's look at 14 and see if it goes into 42. I know that 14 times 2 is 28, but if I do 14 times 3, 1, 2, 3, 3 times 4 is 12, carry the 1, 1, 2, 3, 4. That is 42. So 14 is going to be my greatest common factor. So I've got 28 times 2, or 2x, and plus 42. 42 is going to be 14 times 3. So the correct answer is going to be the greatest common factor is 14 times what is 28x? Well, that would be 2x because 14 times 2 is 28, plus what number times 14 is 42? That's going to be 3. So it's going to be 14 times the quantity of 2x plus 3. These are the other factors that you multiply. Of course, you see the 2x goes with 28 because 14 times 2x is 28x. And the 3 goes with the 42 because 14 times 3 is 42. So that's why we have it in that order. There's more than one way that you could write that and distribute it. You could put it in like a different order here. They're counting that correct because of the commutative property. You could put the parentheses first and then the greatest common factor, and you could change up the order of that. So that's the different ways that you could write it. I always try to keep it in order because it's easier for me to recognize, especially if I'm doing different things like roses and daisies or cupcakes and cookies, whatever the objects are. Number 15, Marissa is buying 5 packages of crackers at $3.10 each. Use mental math and the distributive property to determine how much change Marissa will receive if she gives the clerk $20. Now, the mental math part, don't let that freak you out because we're just taking the 5 packages, that's how many you have, and we're multiplying it times the number of dollars and the number of cents. That's my $3.10. So the 5 times 3 would be $15. And the 5 times 10 would be 50 cents. So the amount of money that she's spending is going to be $15.50. And if you didn't want to do it mental math, you could just multiply the 5 times the $3.10 and you would still get the same thing. And to find out the answer to the question, you're going to take your $20 and you're going to subtract the 1550, or you could take 1550 and count up. But if you can't do that easily in your head, I know that 15 is 5 away from 20. This is a little bit more than 15, so that's going to be 4.5 or 450 more. But if you can't see that that's $4.50, you're going to regroup. That's going to be 1. That's going to be 10, but we make it a 9 to borrow to come here, and that's a 10. So we've got 0 minus 0, 0. 10 minus 5 is 5. Bring down the decimal. 9 minus 5 is 4, and 1 minus 1 is 0. So your answer is going to be, or the amount of change is going to be $4.50 in change. Hopefully that helps. Now on this, whether you use the mental math or not, you should still know how to do the math operations to work that one out. Okay. And number 16, we're almost done. Number 16 is fill in the blanks using the available answers. Are the expressions 3x minus 4y and 4y minus 3x equivalent? If so, determine what property can be applied to determine that they are equivalent. All right, so when I look at this, I noticed right off the bat that because it's a subtraction problem, the order is going to matter. I know that taking 4y away from 3x is not the same thing as taking 3x away from 4y. But the way that I'm going to prove this is I am going to come up with a variable 4x and 4y to see if they're going to be the same. Okay. Oh, this stupid light keeps turning on. I'm taking too long. That means I'm talking too much. Okay. So looking at this, if I pull in a value for x, I could say x equals 1 and y equals 2. You could really put anything. So if x equals 1, I have 3 times x, which would be 3 times 1 minus 4y would be 4 times, 4 times 2. So 3 times 1 is 3, minus 4 times 2 is 8. That first one would become 3 minus 8, which that's going to be negative because if I start at 3 and I subtract 8, it's going to, 3 is 3 away from 0. And if I go 5 more, it's going to be a negative 5. So 3 minus 8 is actually negative 5 for that side. That's where I have my plugged in my x and y. On the other side where I have my 4y and 3x, if y is 2, and I have 4 times 2, that's going to be 8, minus 3x, 3 times 1, that's going to be 3. So 8 minus 3 is a positive 5. So if you look, you're still subtracting, but you're taking the sign of the larger, and a negative 5 is not equal to a positive 5. Now, that is a zero pair. It would cancel each other out because both of them are 5 away from 0. So they are not equivalent at all. Okay, correct answer, not equivalent. Now, I know that we could have just looked at the answer, but you needed to test it to see. And if you try to just do that in your head, chances are you probably missed it because there were a lot of people who missed this question, and all they could have done or all they should have done was plug in an X and plug in a Y to to test it and determine if they are equal or not. You could plug in any value for x and y, and no matter what you put in, it would still prove to be not equal. All right, and the last question, we're almost done. It says simplify the expression 3a squared plus 1/4 a plus 3 plus a squared plus 4 plus 1/4 a. So I've got 1, 2, 3, 4, 5, 6 terms that I've got to simplify. Now, I'm not even going to look at this until I put this stuff together and have something to compare it to. So if I look at this, I'm going to write all of my a squared terms together. It looks like I only have 3a squared and a squared. So that's going to be 3a squared plus 1a squared, or just a squared. And that is all of my a squared terms. Then I have a's plus 1/4 a, okay, and 1/4 a plus 1/4a. So that's my fractions. And then I have my constants of 3. So plus 3 and plus 4. Okay, so I got all the terms are represented and I rewrote it here. So looking at this, I can put my a squareds together, I can put my a's together, and I can put my constants together. So in simplifying this, if I have 3a squared plus a squared, 3 plus 1 is 4a squared plus 1/4 a plus 1/4 a. Well, you're only going to add the numerators and keep the denominators. So 1 plus 1 is 2 over 4. So that would be 2 over 4a. But remember, that could also be simplified. So that would be 1/2 a if I simplified this term. Those are equivalent, or that is equivalent. So it could be 4a squared plus 1/2 a plus, and then I combine the 3 plus 4 is 7. So plus 7. So I look at what I have here. I have 3a squared. Well, that cannot be right because I have 4a squared. So we've got 3 of these with 4a squared, and let's look at what we have. We have 4a squared plus 1 half a plus 7. Well, that matches the second simplified one, so that one absolutely is correct. Now we want to double check these to see if any of these match what we have, just to be on the safe side, because we did it in two ways. This is actually the simplified version. And when we look at this, I have a 4a squared, yes. 1/4 a, no. So it can't be that one because that doesn't match. Here I have a 4a squared plus 1/8 a, and that doesn't match. So it has to be 4a squared plus 1 half a plus 7. And that, my friend, is how you would work all these out. We just work through all of them, and hopefully everything that we're doing with this you will understand better once you figure out your mistakes. Okay, how do I stop this?